Hey guys, welcome back, and today we'll be discussing the LeetCode question called largest plus sign. Now this question says that we have to calculate the largest plus sign over here. Now in this question we are given two parameters, okay? We are given the n and we are given the fine. And we are told that there is an n into n grid. So for example, your n is equal to 5. So they have said that you have to build a 5 into 5 grid. That's cool. Next thing, they have said that they have placed mine at certain location, and the position of the mines is being supplied with the vector mines, okay? And after these mines are initialized to 0 and all the other elements are initialized to 1. And what you have to do is that we have to calculate the largest plus sign we can find over this entire grid. So as we look here, we can find we define a center, and then we start expanding from the center. For example, here we can see that 1 is a center over here, and we expand to the left and we expand to the right, okay? And you might be thinking, what would be the size of this plus sign? So calculating the size of this plus sign is very simple. You have to define a center. Suppose this is a center, and we consider the center as well. So if we are able to expand in all the direction by 1, that means the size is 1 plus the center size of the center, that is 1 plus 1 2. Okay, so that's how the size of the center is the largest plus sign is calculated, and that's everything you need to know about. Let's get started. And the first thing you have to do is that you have to always come up with a brute force solution, because it's generally good in interview that for this kind of problem you deal with a brute force approach, and then you start optimizing from there. So what you have to do is that, as I said, that they have given the position of the mines. So they have not supplied the actual grid. They have told that, okay, at this position there is a mine, at this position there is mine. But they have not said that, yeah, there is a grid and there is a mine. So what you have to do is that we have to declare a 2D array. In this 2D array, what we have to do is that we have to initialize all these elements inside the grid with 1. You can do this in C++ with the statement over here, and actually it's pretty cool if you can remember this, because I have coded a lot in C++, and this statement is actually very helpful. So if you can remember this, this is great. What it does is that it defines a 2D array with the size of n, okay, n. So if you want to change this, you can just edit this n to create n into m, or maybe of any other size. And if you want to initialize all these elements inside the vector with 1, what you have to do is that you have to supply right here 1 or maybe 0 or something else. So it's pretty cool if you can actually remember this, right? Let's move ahead, and what you have to do next. Next thing is that mark the grid, okay? So they have supplied the mines over here, and using the mines we have to fill the grid with the 0, or we have to fill all the ones where the mines are there and change it to 0. For example, over here, let's say that they have said that at 0, 0 there is a mine. So at 0, 0 I change this to 0. And if they have said that at row first and the column second, so this is the uh, first row, this first row and the second column, so I have to change this to okay 0. That's fine. After doing this, we have the grid ready, and now we can start expanding. So what approach I'm thinking here is that we start iterating all these elements. That's the first thing that comes to my mind. I iterate all these elements and then start expanding. For example, let me select a different color pen. I think brown will be good. So what I will do here is that I will declare a center over here, for example 1, and then I will check if can I move up? Yes. Can I move to the right? Yes. Can I move to the down part? Yes. Can I move to the left? Definitely. So if I'm able to perform this operation, if I can move in that direction and it is not giving an out of bound error, out of bound, that means I can totally do this, right? So I can just keep on doing this. So let's take how this expand function works. Okay, now example that you are at the position of I comma j. Now what you have to do is that you have to start expanding. For example, you can expand to k number of times to the right, k number of times. So k can be just any value, right? We do not know how much it can go to the left, how much far it can go to the right. There may be a zero, so hence we have to stop doing that. And the first thing is that we have to first build a small plus sign and then a large plus sign, and then we have to increase the size one by one. Not all of a sudden we can go to the size of k. Okay. Now what we will do here is that I comma j will test the boundary condition, that if I add 1 to the I, is it not going to the outer bound? Definitely. So if I plus 1 is not exceeding, is not greater than equal to 10, that means it is going out of bound. But if I plus 1 is actually less than n, that means actually not less than n, but less than n, that means it is in the grid itself. Okay, so that is the condition we have to look over here. So similarly, we will have a condition for the left part. The left part will say that, okay, if I subtract 1 from the I, is it not becoming less than 0? If I subtract 2 from the left, it isn't not becoming less than 0, and I will keep doing this. And for example, if I take the value of k over here 1, k can be just any value, and we have to keep incrementing. Like I said, we have to build a small plus sign. So k value initially will be 1, and then I will just increment it. If it is possible to build a k of size 1, we will just go builder and store the larger size. We can calculate of the plus sign. So if k is equal to 2 is possible, then we can definitely do that. Okay, and we can start doing this operation. So the boundary condition over here is that the x plus k, or maybe I can have to change it here, the I plus k should not be equal to greater than n, because it is going out of bound. Similarly, we have j plus k greater than equal to n. This is an out of bound condition, and less than 0, less than 0. Right, so hope we are able to understand the out of bound condition. It's very simple, and if you are able to do this, then we are almost done. What you have to do is that when we select a center, we will try to call an expand function. What this expand function take as a parameter is it takes I, j, k, m, n values. Okay, so k is the position of the whatever you can k is the size here. Initially it will be k is equal to 1, k is equal to 2, so we have to keep incrementing. So if this function returns true, that means we have to increment the size of the k, and we have to call this function again and again. So let me show you how this function works. And one more thing, guys, you have to remember that these plus sign, all these values has to be 1. And if you think in the terms of true and false, if this if I do AND operation of all these four different variables, or these four different values, 1, 1, 1, that means it has to return true. So I do a return statement only and only, I call this a true only, if all these values are becoming true. So for this, I will return something like, I will do an AND operation with the this part, this part, this part, this part. So you can easily calculate this. As I said here, you have to just subtract with the k, x minus k, and this will be x minus k. This will be uh, x plus k, x plus k, and right, and this will just go ahead, and we have to keep calculating it. And that's it, guys. What you have to do, and this function, this is a brute force approach. And we have to keep expanding it. And the last thing you have to remember is that we have to store the maximum as well. So if the maximum of this k is equal to something 2, then we have to compare with the previous maximum value. The previous maximum value is storing something 3, we do not have to change it. If the previous maximum is storing something like 1, we have to actually change it and initialize to 2. So this is how this function is going to work. And I hope you are able to understand the brute force approach. Now, for the dynamic programming approach, let me tell you, this is a very simple thing. It's actually the least thing. I just have to tell you one line, and you're able to understand this whole uh, concept as well. So what you have to do is that, whenever let's take this grid for example, right? So what we have to do is that we have to take the summation of the largest one we can find from the left, right? So let's start here. If what is the okay, we have to store the largest number of one we can actually find. So for this, we will build a another grid. Similarly, we'll build a grid for the right one, and similarly we'll build a grid from the right, up and down. So when we start initializing it, what you're going to do is that if the initial is 0, that means there are no 1 at the left part. Okay, we are talking from the left, and if we take this 1 over here, how many ones are there on the left part? 1. And if we take this another one, how many ones are to the left? 2. And this will keep going on, and this is how we'll initialize the whole left part. Now talking about the right part. Okay, let's start over here. In this, if we consider the 0, okay, if we consider the 0, how many ones are to the right of the 0? That is 3. And how many ones are to the right of this one over here? 2, because 2 ones are right of this one, and similarly 1 and 0. So this is how we'll build a function, okay, or maybe we call it grid. We'll build for the up, and we'll build it for the down. Now what we'll do at the end is that we'll start comparing different values, right? So suppose there will be some value called 2 over here. Okay, sorry for that. I'm sorry, the upper part cannot. So suppose there is a random value over 2 over here. So basically what we'll do is that if we find a 1 over in the original grid, like here, what we can do is that we have to check the up value for this one, okay, if the and the right value for this one. So suppose this is coming to be 3, this is coming to be 2, this is coming to be 1, and this is coming to the 2. That means here for any one, for this particular one, there are 3 1 to the left of this one, okay, and 2 ones to the right of this one, and 1 1 top and okay. So when you imagine it, it will be something like this. The grid will be something like this. And trust me guys, if you are able to understand this, it's done. So what you have to do is that we have to actually select the minimum out of this. So the minimum out of this is actually 1, and that's it. That's the answer. So thank you guys for watching the video. I hope you like it. Do like and subscribe and share with your friends. And if you're not able to understand the code, or maybe you're not able to write the code, I request you to write the code for yourself. And if you need any help there, and if you're facing any trouble, let me know in the comments. Thank you.